Welcome to your Algebra 2 Lesson 8.4, Multiply and Divide Rational Expressions. So, guess what? Your objective today is that you will multiply and divide rational expressions. Okay, first we need to talk about simplifying just a single rational expression. Basically, the same concept is reducing a fraction. Okay, it's the same concept. It's just that with these rational expressions, when you have polynomials involved, you have to actively determine what the factors are before you can reduce. When we're just reducing a number fraction, a lot of times you can go, oh yeah, I can take a 2 out of both of those and go the 2 cancels and move on. But here we're going to put a little more thought into it. But again, it's basically factor then cancel and you're good to go. All right, so let A, B, and C be non-zero real numbers or variable expressions, then the following property applies. If you can factor the top to be A times C and the bottom to be B times C, you can divide out the common factor C and reduce to A over B. All right, we're going to simplify a rational expression. So if you notice here, we've got x squared minus 2x minus 15 divided by x squared minus 9. If you have polynomials, in other words, if you've got pluses and minuses in there and you've got variable terms, then you are going to have to actively factor and then reduce. So right now somebody might be thinking, oh, I'm going to cancel out something. No, you can't yet because we haven't factored. You have to factor first. All right, so we're going to factor the numerator and denominator. The numerator factors pretty easily. You can use the AC method. Guess and check or trial and error works pretty well here. So you put your x in your x, and then for the numbers, you think of things that multiply to be negative 15 and add to be negative 2. So plus 3 and negative 5 work. Okay. Then on the bottom, you factor x squared minus 9. We've got difference of two squares there. We got dots. So we're going to factor those out, and we get x plus 3 times x minus 3. Now, if you look on top, we factored to 2 binomials. On the bottom, we factored to 2 binomials. Whenever you go to cancel binomials, it's all or nothing. Okay? The whole entire polynomial has to match up, or you cannot cancel it. I can cancel x plus 3 with x plus 3 because they match up exactly. I cannot cancel this x plus 3 with that x minus 3 because of the minus. They don't match up exactly. It's all or nothing. All right, so we're going to divide out the common factor, the x plus 3's, because they match up exactly, and we're left with x minus 5 over x minus 3. Now, every now and then, I have somebody who wants to cancel out those x's. We can't because it's not x times negative 5 and x times negative 3. If that were the case, we could. But it's x minus 5. It's a binomial over x minus 3. That's a binomial, and it's all or nothing. They have to have everything in common. You completely match up, and then you can cancel them. Otherwise, they stay in. So that's it. That's your answer. Okay. So, multiplying rational expressions, again, very much like just multiplying fractions. Let A, B, C, and D be non-zero real numbers or variable expressions. The rule for multiplying rational expressions is the same as the rule for multiplying numerical fractions. Multiply numerators, multiply denominators, and write the new fraction in simplified form. So if I have A over B times C over D, I am going to have AC over BD. Okay, you multiply the tops together, multiply the bottoms together, and then you simplify by factoring and canceling if possible. All right, what is the simplified form of 8x cubed y over 2xy squared times 7x to the 4th y cubed over 4y? Now this is nice because those aren't polynomials. Those are all monomial expressions, but let's work through with our process. We're going to multiply the numerators and the denominators. So 8x cubed y times 7x to the 4th y cubed equals 56x to the 7th times y to the 4th. So we multiplied our numerators together. Now let's multiply our denominators together. 2xy squared times 4y is going to give us 8xy cubed. We're going to factor and divide out common factors. Now, technically on this one, because they're monomials, you don't have to show the explicit factors, but I think it might make it easier And then I also think it'll make it easier to generalize to polynomials. All right, so considering the 56 and the 8, because those are our numbers, you kind of think of, okay, can I factor an 8 out of the 56? And we can. We can rewrite 56 as 8 times 7. All right, x to the 7th, can I break off an x? I sure can, and I can rewrite it as x times x to the 6th, and that way I can see to cancel the x we broke off with the x in the denominator. Okay, I look at my 2 powers of y. I've got y cubed on the bottom and y to the 4th on top. So I'm going to take the one with the larger exponent and rewrite it as with factors that include that expression with the smaller exponent, so y cubed times y. And that may make it a little easier to see what factors you can cancel. Otherwise, just reduce like we have been. The 8's cancel, the x's cancel, the y cubes cancel, and so we're left with 7x to the 6th times y. So the correct answer is B. All right, now we're going to look at some that actually have polynomials in them. We've got 3x minus 3x squared over x squared plus 4x minus 5 times x squared plus x minus 20 over 3x. Okay, so our solution is going to involve recopying the original expression. That should be an x squared. That's driving me nuts. 3x minus 3x squared over x squared, not x2, x squared plus 4x minus 5. It should be written correctly on your notes. Times x squared plus x minus 20 over 3x. And now we're going to factor. So out of the numerator here, we're going to factor out 3x. Okay, both terms have a 3, both terms have an x, and so then we're left with 1 minus x. X squared plus 4x minus 5 means we're going to have x and x. Numbers that multiply to be negative 5 and add to be 4 are negative 1 and 5. X squared plus x minus 20. We need numbers that multiply to be negative 20 and add to be just plus 1. So we're going to have 5 and negative 4. 5 times negative 4 is negative 20. 5x minus 4x is just 1x. And then 3x. Okay, so now we're going to multiply numerators and denominators. So we're going to have 3x times 1 minus x times x plus 5 times x minus 4 over x minus 1 times x plus 5 times 3x. Okay, all right. Now we're going to rewrite 1 minus x as negative 1 times x minus 1. Well, why would it be negative 1 times x minus 1? Well, if we just switch the terms, we're going to have negative x plus 1. And that's kind of awkward to have that negative in front of the x, so we're going to factor out a negative 1. Okay, so we're going to have 3x times negative 1 times x minus 1 times x plus 5 times x minus 4. And then we're going to have x minus 1 times x plus 5 times 3x. Now we're going to divide out common factors. So the 3x cancels with the 3x. X minus 1 cancels with x minus 1. X plus 5 cancels with x plus 5. And x minus 4 and the negative 1 don't match up with anything, so they're going to be part of our final answer. So we have negative 1 times x minus 4, which gives us negative x plus 4. Go ahead, since it's just a negative 1, go ahead and multiply it through. Okay. For example 4, we've got x plus 2 over x cubed minus 27 times x squared plus 3x plus 9. So we're going to write the polynomial as a rational expression. Anytime you're multiplying a fraction by something that's not in fraction form, whatever's not in fraction form like this polynomial, just pop it over 1. You're not changing the value of it, just the form. So now we want to factor the first denominator. So x cubed minus 27, that is a difference of cubes. We've got dots there. So remember, 27 is 3 cubed, so it's x minus 3 times x squared plus x times 3, so 3x, and then we always end with something positive, so plus 9. And then we went ahead and in the same step, we multiplied our numerators together. So we have x plus 2 times x squared plus 3x plus 9. We had the factored form of x cubed minus 27. We could put times 1, but that's not going to make a difference in what our final answer is. Okay, so remember it's the all or nothing principle. You're going to cancel out anything that matches up completely with something else. So we've got x plus 2 over x minus 3. Those don't match up exactly. We've got x squared plus 3x plus 9 and x squared plus 3x plus 9. So those trinomials cancel out. And we're left with x plus 2 divided by x minus 3. Okay, and that's it. All right, so the last thing that we need to talk about today is dividing rational expressions. To divide one rational expression by another, multiply the first expression by the reciprocal of the second expression. So flip the second one and multiply. So a over b divided by c over d is equal to a over b times d over c. And then you multiply the top together to get AD, you multiply the bottom together to get BC, and then you simplify AD over BC if possible. So at that point, you want to make sure you're looking at your factors, and then you cancel factors that match up exactly. All right, so we're going to do 7x divided by 2x minus 10. That whole fraction divided by x squared minus 6x over x squared minus 11x plus 30. So after you recopy the problem, you're going to flip the second one and multiply. We're going to multiply by the reciprocal. So we've got 7x over 2x minus 10 times x squared minus 11x plus 30 over x squared minus 6x. So now we factor. You flip, factor, and cancel now. We factor. 7x is a monomial. You can see it's got a factor of 7. It's got a factor of x. X squared minus 11x plus 30. You can do the AC method if you want. It's pretty easy to do. Just guess and check. Because of the x squared, you're going to have x and x. Numbers that multiply to be 30 and add to be negative 11 are negative 5 and negative 6. Let's see. Down here, 2x minus 10, we can factor out a 2. And so we get 2 times the quantity x minus 5. For x squared minus 6x, we can factor out an x. So we'll have x times the quantity x minus 6. All right. Now, technically, we are multiplying the tops together and the bottoms together, but we don't actually carry out the multiplication like we've refrained from doing before. We're going to cancel out common factors. So we have 7 times x minus 5 times x minus 6 over 2 times x minus 5 times x minus 6. Now, 7x really is two different factors. We've got 7 times x there. The 7 does not match up with anything. We've got a 7 and a 2. The x matches up with the lone x on the bottom, so those two cancel. X minus 5 is a factor. X minus 5 cancels with the x minus 5 on the bottom. X minus 6 is a factor and matches up and cancels with x minus 6 on the bottom. And so we are left with 7 halves. And that is the simplified form. Okay, last example, always a good time in the lesson. And then you'll be ready to do the problems to try on your own. We've got 6x squared plus x minus 15 over 4x squared divided by 3x squared plus 5x. Now, anytime you're working with a fraction and a non-fraction, remember you can put it over 1, or you can just think in this case of, okay, I'm going to multiply by the reciprocal. So the reciprocal of 3x squared plus 5x is 1 over 3x squared plus 5x. Okay, so now that we've flipped, what do we do next? That's right, we factor. Now, 6x squared plus x minus 15 is a little more challenging to factor with guess and check, but you can probably do it. If not, do the AC method. So let's see. 6x squared, we can do 3x and 2x. Now, whenever we start to see if what we guess checks, remember you're going to do the outsides together plus the insides together and see if they add up to be 1x. Okay, so we've got negative 15. So we're going to need a positive and a negative. Let's try plus 5 and minus 3, and let's just make sure that this works. So if I do the outsides, I get negative 9x. I do the insides, I multiply them together, I get 10x. 10x plus negative 9x gives me 1x. So I know I have factored this correctly. Okay, 4x squared is a factor there. It's just 4 times x squared. And then 1, nothing to factor there. 3x squared plus 5x, we can bring out a common factor of x. Okay, so we're going to multiply our numerator together, our denominator together, then divide out the common factors. So we've got 3x plus 5 times 2x minus 3 times 1. There's no reason to put the times 1 there. So we've got 4x squared times x times 3x plus 5. If you wanted to, you could go ahead and write that as 4x cubed, but you don't have to. That's the big thing. You don't have to think about that. Just write all the factors in their appropriate spot and then cancel out what matches up. So 3x plus 5 matches up with 3x plus 5. 2x minus 3, there's not another binomial on the bottom to even possibly match up. So we're left with the 2x minus 3 on top, and now for sure you want to multiply the 4x squared times x to give you 4x cubed. And that is it. Now, again, someone might think, well, can I cancel the 2 and the 4? No, you can't, because that 2 is not a factor of the whole numerator. It is part of the factor that was 2x minus 3. So it's all or nothing. Okay, you have to be able to cancel all of the numerator with something with another factor in the denominator, and we can't do that here, so we are done. Okay, guys, that's it for this lesson. Do the problems to try on your own. If you don't understand the material enough to do the problems to try on your own, come in and see me, and we'll go over some of the concepts, and I can help you do the problems to try on your own so that you are ready to do your rounds whenever you come to class next time. I will see you soon. Have a good day.